Another problem. The problem here is the position vector of a particle is given. The position vector of a particle is given by r vector equals t cube by 4I plus 3t square j. So since it is a position vector, the unit here is meters. Determine at t equals 2 seconds A. What is the radius of curvature of the path? B. Find out normal and tangential component of acceleration. NT components of acceleration. So how do you solve this? It is very simple. That see here you are given a position vector. You know r vector is xi plus yj for a planar translation, curvilinear motion, 2D curvilinear motion. You will have x component motion and y component motion, or x and y coordinate put together will give you position of particle on a path at any point of time. This x and y, we know they are function of time. That's what is given in this problem. So this x is given as function of time, which is equal to t cube by 4, and y is given again function of time, that's equal to 3t square. So now you are asked to find out this. So the moment you see radius of curvature, you should have, if I have my path equation, I can write my radius of curvature given by the formula. What was the formula that we have seen? Rho equals, if path equation given, if path equation is given explicitly, we have looked at rho means this is the formula will come in our mind, dy by dx whole square whole power 3 by 2 divided by d squared y by dx square. But you see here, now we are not given path. So here, coordinate variation function of time. That is where you are given state equation means time, dt is my velocity vector, and dv by dt is what is my acceleration vector. So if I know my velocity and acceleration vector, I can also find out the rho simply. That's where in the last class we looked at the relationship. What is that? We can rewrite this as vx square plus vy square whole power 3 by 2 divided by Vx Ay minus Ax By. This relationship. So I require velocity vector and acceleration vector. So I will be able to fill in this formula, and I will know what is my radius of curvature. Right? So accordingly, you should use the formula. So now it's very simple, straightforward. We can start solving the problem where r vector is given by, in the problem, t cube by 4I plus j. So as the vector will be 3t squared by 3, so 12I plus 6tj. What is my acceleration vector? This is going to be 6t squared by 12. So it is 60 by 12 I plus 6j. So I have here t by 2I plus 6j is what is my acceleration vector. So look at this acceleration vector. I have x component of acceleration. Ax is varying as a function of time, whereas y component of acceleration is constant. Velocity vector it's like this. So that if position vector x is of order 3, then acceleration is variable. If x is of order 2, acceleration is constant. So this relationship already we have looked at in motion curves. So now you have got your velocity vector, this all, and it is very straightforward. At time is equal to 2 seconds, we are asked to get the radius of curvature. What is the NT component of acceleration? So at t equals 2 seconds, now I can rewrite what is v vector at 2 seconds as I will be able to write 2 square by 4i plus 6 into 2j. So now I plus 12j. What is my v2 vector? I plus 12j. Right? Am I doing correctly? Yeah. And similarly, now what is my acceleration vector? That's going to be 2 by 2 I plus 6j. Yeah.
So how did you get in the velocity vector after the differentiation? How did you get like 12 in the denominator?
No, see, it is x. What is x is equal to t cube by 4. So differentiate dx by dt. That's going to be 3t squared by 4. Oh, sorry, this is
Yes.
4. Sorry, this is 4. Yeah. 6 by 4. And here it is 60. So this is going to be 3 into 2 squared by 4. I'm sorry. Into this. So here I will have 3i plus 12j, right? 3, thank you. So 3i plus 12j is what is my velocity vector, and acceleration vector, I think now accordingly it will change. Yeah. So this, if I differentiate here again, it is 60 by 4. 60 by 4. I'm sorry, 60 by 4. And this is 6. So when I put here t equals 2, that is 12 by 4. So 12 by 4i plus 6j. So that's going to be 3i plus 6j. 3i plus 6j. So my acceleration vector is this and my velocity vector is this. So now I can find out what is my rho. There are different way of doing it. So I can substitute this in this formula. What I have written it here. So I know what is Vx, Vy, Ax and Ay. I can substitute and find. Or I can also use this third relationship, what we have seen in the last class. What is that? A cross V equals V cube by rho, right? So I can also use this relationship to find, sorry, this I will use to find my normal and tangential at that time. So this I can use it. Now let us find first the rho. First rho, how do I get? You can also use this, right? So I can find this determinant from these two vectors and I can equate to this. So what is my v vector modulus? It is under root of 3 square plus 12 square. So that's going to be 3 square plus 12 square. It's 12.3, 12.37 meter per second. So I have this and I can find this determinant. I can also use this, right? So it is going to be I, J, K, acceleration vector is 3,360 and this is 3,12,0. So this determinant is what is equal to 12.37 square by rho. The modulus of this determinant is what is so this modulus of this determinant is what is going to be equal to this. So I can find out that that's going to be I into 0.0 j 0 k. It is so k into 36 minus 18. right? 36 minus 18. I into the 0 minus j 0 plus k into k into this is right, a cross v only we have written that expression. Last class we did write a cross v, correct. So you have this now. So this modulus is what is 12.37 squared by cube by rho. So this solves for rho. So since it is a unit vector, its modulus is now 18. So rho will be 12.37 cube by 18. So you get cube divided by 18. So 105.1 meters. So that is your radius of curvature. At that time instant 2 seconds, at t is equal to 2 seconds. So next time instant this will be varying because your velocity and acceleration is varying as function of time. So you have this rho. So once you have this rho, then it is easy for you to calculate what is the nt components. So how do you get n and t components? So you have a n component given by, let me finish it in this page itself. You have a n is v squared by rho. So I can substitute 12.37 squared by found out rho, and that's going to be equal to 12.369 square divided by 105.1. So that's going to be 1.456 meter per second square. That is your normal component of acceleration, which is responsible to maintain the direction of translating particle. And now what is my AT? How do I get AT? I can express my total acceleration here, whatever that I have. Here acceleration 2 is expressed as ax2i plus ay2j. Subscript 2 is referred to the time instant. So rectangular components represented. So what is my modulus at that time? That would be under root of 3 square plus 6 square. So I will have 3 square plus
6.7.
Yeah. So 6.71 meter per second square is what is my magnitude of the acceleration. T is equal to 2 seconds. So this can be expressed now also as this. So the total acceleration A2 can be expressed as AT2 vector plus AN vector, right? I can also represent this way. So now I require this magnitude. So how do I get that? The magnitude, this, like I represent ax square plus ay square, I can also represent the magnitude of this as at2 square plus an2 square. So if I have this, I would be able to have my at is under root of a2 square minus an square. That's all. That's going to be a2 is 6.71 square minus an is 1.456 square. That's going to give me what is my at. So this square 45 minus 1.456 square root of answer is 6.548 meter per second square is what is my AT. So you are able to get tangential component of acceleration. So now this is the magnitude only. So this is not constant. AT is not constant because A is not constant. The magnitude you get it at 2, but it is function of time. So you will, this AT value will be different when t equals 3 seconds, right? So when the acceleration is constant here, AT, you have 6 motion equations, which you have already discussed in a rectilinear motion. So you have to account like this. So this component is responsible for change in magnitude of velocity. And this component is responsible for maintaining the direction of motion. Very important understanding. That's why you are asked NT component. So if I have this, I know how do I control my direction of motion. And if I know AD, how my motion parameters varying along the path. That means what is the change in velocity, amplitude of change in, means magnitude of change in velocity. So what is the change in speed? What is the change in position? All to calculate, I require this AT, right? Yeah. So we will take one more problem of this, and then we'll take a special problem, what is called a projectile motion problem, right? So let me put you on another problem here. The particle moves along a curved path. The path of the particle is given by y